All right, AP Calculus AB, using the fundamental theorem of calculus to find area. And here we're asked to find the area of the region bounded by this function, y is equal to 2x squared minus 3x plus 2, the x-axis, and two vertical lines, y equals 0 and, x equals 0 and x equals 2. So what I've done so far is I started to draw a graph of this function. It looks like this, doesn't it? So here's we have this boundary here at the x-axis. We have this boundary here at x is the line, the vertical line, x is equal to 0, and x is equal to 2 here. So the area we're looking for is the area in this little shape here. Not a very difficult thing. We're going to use the fundamental theorem of calculus. So the first thing I'm going to do is I'm going to pull this piece out here, and I'm going to start to integrate this. So I'm going to start to integrate this, and so what we're asking for now is we're asking for, we need to use a different pen, sorry, 0 to 2, right, of 2x squared minus 3x plus 2 whole thing dx. So on the exam they want you to use proper notation, so you'd have to let them know that you understand what you're being asked to find here. So it's that. From here I'd start to integrate, and I'm going to integrate this thing this way. I look at the interval that this is on, and there's no problem, and I'll show you what this means in another video. I hope you're going to watch that one on integrating taking definite integrals of absolute value functions, because they're a little bit trickier sometimes. But I'm going to go ahead and start to integrate. So here's my integration of this, I think, and I'm going to use correct notation here. Here, this is going to be 2x cubed over 3, isn't it? This is going... I'm going to integrate the second part, which is going to be 3x squared over 2. Isn't that right? And the first integral of this is positive 2x. And hopefully all this makes sense to you. If you can't figure out how I'm integrating this, this is kind of the wrong video, and I hope you'll go back and look at another one that I've done. But this is assuming you know this part, and just how are we going to use the fundamental theorem of calculus here. And we're going to evaluate this thing from 0 to 2. So this would be your correct notation here. Probably I would say to, I'll probably say to my reader that area is equal to f of b minus f of a. You don't need to use this notation because you're saying it, but it's FTC, the fundamental theorem of calculus, and that's what we're about to exercise here. So we're going to take f of 2 minus f of 0, and we're going to evaluate that. And that looks like this, I think. All I'm going to do is take this, and I'm going to take 2x cubed, right, over 3 minus 3x squared over 2 plus 2x, right? That's this part right here. This part right here. That's what we have here, right? We have this thing here, don't we? And now I'm going to do the other part. So minus f of 0, and that would be 0 minus 0 minus 0. I think that makes sense, doesn't it? Because each one of these terms, if I put 0 in, each one of these terms would go to 0. So that's where I'm getting that. Here I'm going to go ahead and I'm going to plug in my b value, which is 2. It's the upper bound. And 2. I'm going to try to simplify this a little bit. We're going to get 8 16/3, aren't we? Minus, what is that? 4 12 halves, which is 6, isn't it? Plus 4. Negative 6 plus 4 is negative 2, isn't it? I'm just cleaning this up, negative 2. I'm going to go ahead and keep doing my work here, and going to turn this into thirds. This into thirds. So 2 in the form of thirds would be 6/3 is the same as 2, isn't it? And 16/3 minus 6/3 is equal to 10/3 equals area. And that's what my notation would look like if I was lucky enough to be taking the AP Calc exam. So make sure when they ask you to find the area, if this is on free response, that you set it up as an integral, that you integrate, and that you show this evaluative notation here. I would definitely, I think you'll have time to do this, show that I am using the fundamental theorem of calculus, either by showing this or by mentioning FTC. And then I would show this work, and I would make sure that I have this as my final answer circled. All right? Think you guys have this. This is not terribly hard. It gets it gets trickier. Make sure that your integration skills are good, and then become familiar with the fundamental theorem of calculus. So, hey, thanks for watching. I really appreciate it, and I hope you'll take time to look at my next video that I'm doing right now, which is evaluating an integration of an absolute value function. So, all right, thanks for watching.